Hi, in this video I'll be showing you how to find areas underneath curves. Let's begin. I'm going to first draw a diagram. I'll be putting a curve on this diagram and I'll call it y is a function of x. I'll put the 0 here below. And now I'm going to draw a line through this curve. The first line will be called x equals a. The second line will be called x equals x. The third line will be called x plus change in x. And the fourth line will be called x equals b. Now, I'm going to name two regions underneath the curve. From x equals a to x equals x, we'll have an area called a. And from x equals x to x plus change in x, we'll have a region called change in area. Now I'm going to put 6 points on this diagram. The first point is going to be called P. The second point is going to be called M. The third point is going to be called T. The other point, parallel to P, is going to be called N. This point here will be called S. And the point parallel to S will be called Q. Now, the point P will have the coordinates x, y. So this line here is y. The point Q will have the coordinates x plus change in x, y plus change in y. So this line is y plus change in y. Now that we've drawn the diagram correctly, we can begin finding out how to find the area underneath a curve. Now, going back to the diagram to our left, let's name this width over here. Let's call it change in x. And let's name this height over here. Let's call it y. And let's name this height over here. Let's call it change in y. So in total, this height here is y plus change in y. Okay, so let's look at the area of the rectangle PMTN. We can see that the section change in area has a bigger area than the rectangle PMTN. So I'll put change in area is greater than the area of rectangle PMTN. Now, the section change in area does not have a bigger area than the rectangle SMTQ. The area of the rectangle SMTQ is larger than the area of change in area. Now, what is the area of PMTN? It is actually the height y multiplied by the width at change in x. And the area SMTQ is the height y plus change in y multiplied by the width change in x. Now, as we've got this equation here, let's divide everything in it by change in x. What we're left with is change in area over change in x is greater than y, but is smaller than y plus change in y. Now, as many of you know, as change in x approaches 0, change in y approaches 0. We also know that in the limit, as change in x approaches 0, change in area over change in x becomes dA over dx. In the limit, as change in x approaches 0, change in area over change in x becomes y. Now, if you're wondering why this is the case, as I said earlier, as change in x approaches 0, change in y approaches 0. And if change in y approaches 0 and becomes very, very small, change in area over change in x practically becomes y. This is why what I've written below here makes sense. Right, using this information, we can say that y equals dA over dx. Multiplying both sides of this equation by dx, we get 1 dA equals y dx. Now, what we're going to do here is integrate both sides of the equation. So we end up with area equals integrate y dx. And that equals a function of x plus a constant. Now, this function of x is not the same as the function of x of this curve. Don't mix the two together. It's the function of x you get after you've integrated y dx. Now, from here, what we have to write is area equals function of x plus a constant. Looking at the diagram over here, at x equals a, the area is 0, because on this line no area exists. So remember, this a here is this a here. It's this section underneath the curve. So when x equals a, this area is 0. So, looking at this, we can change the area into 0, we can make x become a, and we'll keep the constant here. Therefore, the constant is minus function of a. Therefore, the area is function of x minus the function of a. And this area is the section underneath the curve right here, from x equals a to x equals x. Now, if you want to find the area underneath the curve from x equals b to x equals a, you need to use this equation right here. It's area equals integrate. So you'll be integrating from x is b to x is a, y dx, which equals function of b minus function of a. And as I said earlier on, do not get this function over here mixed up with the grand function here, the big F, which is a different function of x. So, if you're looking for areas underneath the curve from x equals b to x equals a, you use this equation right here. If you have any questions, please leave your comments below. Thank you for watching.